Alright, welcome back to week 8, part A. So in this video we are going to talk more about tracing recursion by hand. So we saw one example of me doing that earlier with that print triangle function call with side length to 4. But now we're going to sort of define the process that I showed you earlier in a way so that you can reproduce the same process with any recursive function call. Alright, so this is sort of my approach for sort of handling recursion and figuring out on paper what it's going to do. So first thing I do is I create an outline, and you saw me doing this. So when I create this outline, I basically read the function top down, and I make one pass through the function, meaning I just sort of outline the different things that the function is going to do, and I just go top down. If there's any function calls, I sort of make a note of them so that I can go back to them later. And the way I did that in the previous example that you saw was that I drew a circle around function calls. That way I knew, okay, I'll have to come back to this function call later and deal with that. So then once you make that outline, you just sort of write out top down what the function is going to do, making note of any function calls. Then what you do is you revisit the same outline and you see, okay, are there any function calls here? If there are, then write the same sort of outline for that function call, right? And you saw that with the print triangle one. And again, just do the exact same thing. Just write out the outline for that new function call, go top down. If there's any more function calls, make notes of them, circle them, and come back to them later. Then once you have your sort of outline drawn out, then you go back to the beginning and sort of pretend like you're at the computer running through the code. So this is sort of a two-step process. First you do the outline, and then you actually run through the outline. So when you're running through the outline, you start from the beginning, and then the rule is you just go top down, but if you hit a function call, you have to do everything in that function call first, then you can come back to where you left off. So if you hit a function call, if you hit something that's circled, you got to do everything there first, then you come back and finish the rest of the code. We'll do a couple more examples just to make sure this sort of outline and then go through the outline process makes sense. But of course, if you have any questions about it, please do let me know. Alright, so let's do another example with this print triangle function. This is the same print triangle function we talked about before. So I already did one outline with side length set to the argument 4. Let's do it again just with side length set to the argument 3, just to sort of run through it again, just to make sure we're all sort of on the same page with that, but I will do a smaller triangle this time, just to make sure we have enough space on the drawing board. So again, the whole point of this is so that if I give you code that uses a recursive function call, that you can figure out sort of by hand what's happening, and that way, you know, you can sort of internally know, okay, this is what the computer is doing. This is how it handles recursion. So again, with these outlines, two steps. First you draw the outline, then you go back and actually sort of run through the outline. So first step, we'll draw the outline. So the function call that we're dealing with is print triangle 3. I'm going to, again, use this just shorthand notation for print triangle, just because I don't want to write out the whole thing. So this is the function call that we're doing. Print triangle 3, and we're going to write a little outline of what it's going to do. So again, the outline, you just run through the code top down and just sort of make an outline really of what the code is going to do. So running through this code top down, this is side length, right, that 3. So we do this if check, if side length greater than 0. Yes, 3 is greater than 0. So then we're going to do these two lines of code. Two lines of code that we're going to do is print triangle of side length minus 1. Right now side length is 3. So side length minus 1, going to be 2. And we'll note, hey, this is a function call. Remember, you want to make note of anything that is a function call. And then the next thing we'll do is we'll do this print statement. We'll print, you know, this thing side length times. Now again, in this case, side length is still 3. So side length is still 3 because we're still in this box here. So we'll print this 3 times. Awesome. So now we revisit this outline, we look at it, and we say, okay, are there any function calls? Yes, this thing that I circled. So now we'll make another outline for that function call. So same sort of idea, print triangle, now side length is 2. And we'll do the same thing. We'll do this if check, if side length greater than 0. Well, side length is 2. So yes, it is, which means we will do these 2 lines of code. We'll print triangle, side length minus 1. Side length right now is 2, right, because we're in this function call right now. Side length right now is 2, which means side length minus 1 is going to be 1. And then we print out this side length times side length right now is 2, again, because we are in this box right here. Cool. Now we see, okay, here's another function call, right? So we got to do an outline for this one. Same thing, print triangle of 1, and we'll draw out our outline. Side length now is 1. So we do this quick check to see if side length is greater than 0. Side length is 1, which is greater than 0, which means we will do these 2 lines of code in the if statement, which are print triangle of side length minus 1. Side length is 1, which means this is now 0 right here. And then we'll print this. How many times? Well, side length times, and side length is 1. Then we see here, we got another function call. So let's write an outline for that one. Cool. So now side length is 0, which is awesome, because if we look at the function definition, when side length is 0, we do nothing. So we finally hit the end. All right. So this right here, this is just step 1 of this sort of tracing recursive calls by hand process. And I know this seems like a lot, but the thing is, if you don't do this outline, it will be really, really tricky to figure out what's going on. So doing this outline really helps. So at this point in time, we've just done that outline. So now what we want to do to actually figure out the output, and I'll make a sort of area over here that says, okay, this is going to be the output over here. To figure out what this output is going to look like, now we go back to the beginning, which is here, the original function call. And now the rule is we're going to process the code, pretend we're the computer, just run the code top down, but if we hit a function call, we have to finish everything in that function call before we can finish the rest of the code. So we go top down, we do that if check, it's true, which means we do this function call right here. Now, before we go to the next line of code, we have to completely finish this function call. So we hit this function call, and now we have to follow it and run the code for that function call before we come back and run the rest of the code. Same thing, go top down, the if is true, we hit a function call. Again, the rule is you have to do the entire function call before you come back and finish the rest of the code. So we follow this function call to do the code for that one. Go top down. The if is true, we hit another function call, which means we have to completely finish this function call before we come back and do the rest of the code. So we go back, or we go and follow to this function call over here, this print triangle 0. Now, this one, there's nothing to do in it. We just don't do anything. So this is finally the end, which means we have done this. So now we can come back and say, okay, I've done this function call. It did nothing. Cool. Now I will finish finally the rest of this function call here. And this function call here says the next line of code is to do this right here. So we'll go ahead and do that. We'll print out that one time. All right, so now we've finally finished this entire function call, right? So now we can go back to where we made that function call, which was here. We've done that. So now we'll finish the rest of the code. which is this. So we'll print this 2 times. Awesome. So now we've done this. Alright, so now we'll come back here. We've done this function call already, which means we can finally go down and do this code, which is this. And now we're finally at the end of our original beginning function call, which means we've done it. This is the entire code right here. So this will be the output, which makes sense, right? Because we wanted to print a triangle with side length 3. So again, with all these examples, what you want to do is you want to write out the outline first, just sort of outline what the code is going to do. Once you have the outline, of course making note of other function calls and drawing the outline for those function calls too, then once you have that outline, you go back to the beginning and you want to sort of run through the code top down with the rule that if you hit a function call, you need to do everything for that function call before you do the rest. Alright, so I want you to try it on your own, and then we'll come back and do one of these examples. So if I give you this code, and then I give you these 2 function calls. So this function definition, the name of this function is just f because I'm super uncreative. So then the 2 function calls that I want you to sort of figure out what's going to happen are going to be f5 and f6. So what will happen when we call this function with the argument 5, and what's going to happen when we call this function with the argument 6. I want you to try this out on your own, draw out your outline, and then sort of follow the outline to figure out what's going to happen. And then when you're ready to see the solutions, come on back and we'll work our way through it. Alright, so with these 2 function calls, f5 will return 11 and f6 will return 13. So what I'm going to do now, I'm going to go ahead and go through the outline for f5. I'm not going to do the one for f6, but the one for f6 will basically be one more step than the one for f5. But if you have questions about f6 after seeing the outline for f5, please do let me know. Alright, so let's go ahead. I'll make a new blank canvas here so we have room to work with. Alright, so again, we want to figure out what will be returned with this function call here, f5. And here's the code here. Alright, so first thing we do, we're going to go ahead and run through and make our outline of what's going to happen. Alright, so right now, this right here is n, right? Because that's the argument, n is the parameter variable. So when we run through this code, first thing we do is we check and see if n is equal to 1. It's not, right? Okay, cool. So we're in the else case here. We're dealing with the else. So the else says, okay, x is going to be f of n minus 1. N right now is 5, right? So n minus 1 is going to be 4. And then plus 2. And again, we'll sort of make note right here, we have a function call, right? So we're going to have to deal with that later. Alright, then at the very end, we return x. Cool. Alright, so now let's deal with this function call. Right, so again, the rule is when you're making your outlines, if you hit a function call, you're going to have to make an outline for that function call as well. So here's our outline for f4. Now this is as if it's a new function call, right? So this is now n. And we'll just sort of run through the code again. So we first check and see, hey, does n equal 1? It does not, right? So we're still, again, in this else case. And in the else case, what we do is we set x to be f of n minus 1. Now right now, n is 4. So n minus 1 is going to be 3. and then plus 2, and then I'll make another note, hey, this is a function call, future self, you're going to have to deal with that. Cool, and then return x. Awesome. Keep going, right? We still have a function call, which means we need to keep drawing outlines. So this outline here, we have f of 3 is the function call that we are now outlining. In this case, n has the value 3. And we'll run through the code again. Does n equal 1? Nope. So we're still in the else. And the else says, alright, x is going to get the value of f of n minus 1. N is 3, so n minus 1 is 2. Plus 2. And hey, oh look, function call. Yay. Alright, and then we return x. Cool. Alright, we hit a function call though, right? So that means we got to do the outline for this function call too. Alright, f2. This is our n now. Keep writing out the function calls. We're still in the else, right? Because n is not 1. Else, we're going to set x to be f of 1 plus 2. Note that this is a function call. And then return x. Alright, we got this function call here. F of 1. N is 1. Draw our outline. Now this is where it finally gets interesting, right? We talked about how with recursion there has to be sort of a case that handles the simplest input. We finally hit that case, right? We finally hit the case where n is equal to 1. So we're in the if, which means we return 3, which is awesome because when I look at this outline for f of 1, there are no function calls. So because there are no function calls left that I need to outline, I know that I'm now finally done writing my outline. So again, that was sort of step 1 for the process. Now we're going to go back to the beginning, which was here. And we're going to basically just sort of run through and process our outline. So again, when we do this, we go top down. If we hit code that involves a function call, we have to completely finish that function call before we do the rest of the code. So, going top down, we hit an assignment statement. Right-hand side of this assignment statement has a function call, specifically a function call to f4. So what that means is before we can assign this value here to x, we have to figure out what f4 is. What is the result of this function call? Which means we need to go to that function call. So same thing, go top down, and we hit another function call. So to figure out the full result of this assignment statement, we gotta do this function call here. Same thing, we hit another function call. To figure out the result of this, we need to do this function call. Alright, same thing, top down, hit another function call. To figure out the result of this, we gotta do this function call to f1. Now, this is where it gets very nice. When we do this function call to f1, we run top down. We hit the if is true, which means we just return 3. So basically what we do now is, since this is a value returning function, whenever we make a function call to f1, which is exactly what we're doing right here, we can replace that with the number 3, because f1 gives you 3 back. So now we can finally do this assignment statement that says, hey, take the result of this function call to f1, add 2 to it, and then put that into x. Alright, well, we know now that f1 gives us 3. 3 plus 2 is 5, which means we're putting 5 into x. And then when we return x, we're basically returning 5. And now we've finished this entire thing, which means we can come back to where we came from, which was this function call to f2. And I know now, when I say, hey, make a function call to f2, That just means return 5. So now I can replace this with the number 5. I can do this entire assignment statement, which says, hey, x is going to get the value 5 plus 2, which is 7, right? So now here, when we return x, going top down, we're returning 7, which means now whenever I make a function called f3, f3 basically means 7. So this assignment statement here, x equals f3 plus 2, turns into x equals 7 plus 2, which means x is 9. So when we return x here, we're basically returning 9. Now we finish this entire function call, which means whenever we do a call to f4, which we're doing here, right? Whenever we do a call to f4, we can replace that with this, which is 9. So here, assignment statement, x equals 9 plus 2. 9 plus 2 is 11, so here x is 11, which means when we do this function call to f5, we are returning 11, which is what we have here as the result. Something that I do want to point out about this example in particular, these are value returning functions specifically. So, in the previous example with the print triangle, whenever we did a function call, we just printed some stuff. With this one, whenever we did a function call, we actually returned a value. So we would bring that value back to the previous function call and basically replace that function call with the value. Again, that's because it's a value returning function. Another thing that I do want to point out is between all of these boxes, between all these function calls, the variable x is what we would consider to be a local variable, right? So the value of x is specifically a value that only exists in that specific rectangle. So the scope here is, going to be these individual rectangles here. So again, hopefully, if you didn't quite get 11 and 13 for this, hopefully the 11 now makes sense. If you didn't get 13 for f6, I strongly recommend going through this again, but with a function called f6. Now the cool thing about this is when you do the function call to f6 and you write out the outline, part of your outline is going to have x equals f5 plus 2, and we already have the answer to this, right? Because we've already done all this work for f5 already. So we already know that this is 11. So then when you add 2 to it and then return that, you're going to return 13. So the nice, sort of thing with these recursive function calls is once you do a lot of the work, you can sort of reuse it, so like for a test situation, if I give you a recursive function and I say, hey, tell me what the results of these multiple function calls are, you really only have to do the work for the biggest one, and then you can piece out, the smaller pieces, the result of the smaller ones. Now again, that said, if you do have any questions about these examples, please do let me know. But again, even though recursion looks kind of complicated, I'll admit it is sort of a complicated concept, but actually sort of figuring out what the code will do, it's not that bad as long as you, go through that sort of, make sure you write out your outlines in an organized way, make notes of other function calls, and then once you have your outlines, then go back and run through them top down, finishing other function calls first. So just make sure you follow, these sort of rules that I've given you here about how to trace recursion. First make the outline, then go through your outline, and after a little bit of practice, you'll be able to do it really quick. Now that said, for this class, as far as recursion goes, I'm not going to expect you to write recursive code, meaning I'm not going to say, write a function that is recursive and does this. I'm not going to expect you to do that for the test. Instead, for this class, for the test, you should understand, one, how recursion works, just sort of this idea that a function calls itself, and it has those two requirements. It should get easier each time it calls itself, and then there also should be special cases for the smaller requirements. And then you should also be able to trace a recursive function call by hand. So these are all these outlines that we've been doing. So if I give you code, if I say, hey, here's a function that is recursive, or just here's a function, what is the result of this function? You should be able to tell me that. So for a test, you should be able to understand code that is provided and how recursion works, but you don't have to write your own code that is recursive. If you need any clarification on that, please don't hesitate to ask.